In this lecture, I'm going to briefly introduce you the concept of reverse engineering. So why we need to reverse engineer products, the advantages, how do we do that, and what exactly we get out of that exercise. Before moving into details of reverse engineering, I just want you to watch this small video clip.
So let's get straight into it. What is reverse engineering? Reverse engineering is the act of dismantling an object to see how it works. This is primarily done to analyse and gain knowledge about the way something works, but often it is used to duplicate or then improve an object. Many things can be reverse engineered, including software, products, physical machines, and even military technology. In fact, recently the US government raced against China to recover an F-35 stealth jet from the bottom of the South China Sea. It did this precisely to prevent another nation reverse engineering the technology. This gives you a clue as to how effective reverse engineering can be. It's often used in the research stages of a project by designers wanting to make add-on or complementary products for an existing product where they can't get hold of the original design files.
Make sure you watch this video right up until the end, because there's some key things in the last bit of this video that explains how reverse engineering can save you thousands of pounds when you're developing a product.
This is because those original files may have been lost, may never have been available if the product was originally developed by a Chinese manufacturer who hasn't then released the source files and has then subsequently gone out of business.
Reverse engineering can obviously be used by people to copy other people's products, but ethical design companies like D2M Innovation that I founded are never going to do that. The only time we would use reverse engineering is where the client already owns the design and all the intellectual property, and in those cases then there's no issue with using reverse engineering, and often it can reduce overall costs and time to develop a better product.
Well, the reverse engineering process is specific to the object on which it's being performed. No matter the object type, there are three general steps that are common to all reverse engineering efforts. These include information extraction, modelling, and review. Let's look at each of those in a bit more detail. Information extraction is where you study the object that's being reverse engineered and remove or extract the information about its design and then examine that to determine exactly how all the components in a product fit together. In product reverse engineering specifically, dimensions, tolerances, fits and assembly techniques are often the main areas that you want to study. Once you have all that collected information, it's then used to create a conceptual model, often using 3D computer-aided design software. And the purpose of this step is to take all the information that was specific to the original and put it into a new general model that can be used to guide the design of new objects or systems. Review is the final step, and this often revolves around testing various different scenarios, maybe in the computer-aided design environment, or by 3D printing you can test fit and purpose in the real world environment, and you can then manipulate these prototypes to confirm the design intent and then re-engineer the original product to now be better. It's often also used for product improvement, and this is the key driver in most cases. For firms involved in product design, development and manufacture, the need for constant development and evolution is simply part of operating in any competitive market. The main goals of reverse engineering in the context of product improvement are reducing manufacturing cost, refining features for improved usability, improving product performance and durability, replacing a product with a new, updated version. By simplifying a product's manufacture, its costs can often be potentially significantly reduced whilst also improving its performance. As I said at the beginning, how can you use reverse engineering to save yourself thousands of pounds? Well, you can do that by ensuring all the lessons learned in developing your previous products are then captured before you then develop the new product. And then if you've got issues with previous products, like customers have had parts that have broken over time or things that they've complained about in reviews, then you can reverse engineer the original product, but then improve those areas, which will give you a much better product overall. But that will be significantly cheaper than starting from scratch. Don't forget to subscribe and click the bell icon so that you know when we launch the next video in the series. I hope you enjoyed the video.
Okay, so that is all about a brief introduction to reverse engineering by a British company called D2M Innovations. So that, in fact, clearly highlights the key points in this reverse engineering. So as mentioned in the video, so what we are trying to do in reverse engineering is to analyze existing design or device or system in a systematic way to study it as it is, or as a requirement to improve or redesign the existing product. This involves basically three broad steps. One is the information extraction, that is understanding the functionality, the dimensions, and other geometric information of the product. And then you model the product in a solid modeling software like SolidWorks as you use. And then you review the product. You maybe you make the product as it is and do some testing, or on the solid model, you do some simulations using engineering analytical software like finite element software, and analyze the performance and see how we could improve the product. Or whatever the case, there are three broad steps involved in this reverse engineering process. That is information extraction, modeling, and review. Now, for example, if you take a simple product like caster wheel, as you could see here, so this physical product. So in the process of reverse engineering, we disassemble the product, takes parts, each and every part out of the product. So these are the parts of this caster wheel. And then we measure the dimensions of each and every part. And then we model the parts in computer software. And then we could assemble the parts and remodel the product in software like SolidWorks. And then you could analyze the performance of different parts and their interconnectivity and things like that, maybe through software or maybe through real model testing, and see how we could improve that existing product. And then we develop the part drawings or the production drawings of the improved product. And then the final stage, we could manufacture the improved product for the market. So that is basically the reverse engineering process. So the tools that we use for reverse engineering, mostly we could use handheld calipers, the measuring devices, the rulers, vernier calipers, micrometers, etc. Or we can use more sophisticated measuring machines like coordinate measuring machines, particularly when the geometries are too complicated. And then also in present day, we have 3D scanners, so we can scan the object and take that object into a computer model. Or in a simple approach, you can export a picture of the product or the component into AutoCAD, for example, and then using AutoCAD tools, we should be able to measure the radii of this curve section, for example. Like you can fit a 3-point arc on this and get the diameter or the radius calculated. Likewise, you could use export parts into AutoCAD and calculate the dimensions of the complex shapes using AutoCAD tools. Now, if you use such an approach, it is very much important to have your line of sight when you're taking photographs perpendicular to the object. Otherwise, the dimensions will be distorted. So those are the tools that we could use for reverse engineering. So in forward engineering, usual engineering that we know, there is a requirement from for a product and then you develop a concept, and then you design it, and then you make the product. So that is how the new products are formed. On the other hand, in reverse engineering, what you do is you start from existing product and you take that parts of the product out and examine various different parts and how they work, and then you redesign and improve the product and introduce a re-engineered better product. Now, in the forward engineering, you may have to use certain reverse engineering activities in order to properly generate new concepts and generate new ideas, because there are so many products available, so many concepts, ideas, and maneuvering techniques are available for various activities. There is no need to reinvent the wheel. So you could get some ideas from others and incorporate those ideas into your new designs. So why we need reverse engineering? Mostly we need reverse engineering if the drawings, CAD files, solid models, etc. are not available. So you have a product, but the details are not available. And if the original manufacturer does not give you the required technical details of the product, so you have to find yourself the details. And sometimes if you want to improve the product, then you'll have to study the product as it is and see what functionalities could be improved. And then if there are certain parts are worn off or broken, then if you want to replace those parts, then you may need some technical information about those parts. So the reverse engineering would help to find out this required data. So reverse engineering helps us in all these four aspects in understanding or re-engineering product. So this process is more or less to study about how something works, not just to steal somebody's idea and produce some counterfeit products. And at the same time, reverse engineering is a legitimate activity which is widely used in industry. So it's not just stealing. So if you copy somebody's product one-to-one, it is stealing rather. But if you reverse engineer a product and get an idea about how the product works, and then with that knowledge, if you can come up with something new, something better, that is what is required in product development. So that is why this process of reverse engineering is identified or recognized as a legitimate activity in industry. So the advantages of reverse engineering, we could explore the existing designs and maneuvering methods of different products. And it helps us to reconstruct the product, which may be outdated. So you study the product and get the drawings done and reconstruct a new product. And it helps us to discover the product vulnerabilities. There can be certain parts which are more prone to fail. So you can understand or identify certain critical components which could fail in normal operating conditions. So you can discover these vulnerabilities or things which could be improved, and then you can take measures to improve it later on. And also, these kind of exercises will inspire creative minds with all ideas. That is, if you are run short of ideas, doing reverse engineering exercises, you come to know certain things which people have used in executing certain activities. Accordingly, you will get some new ideas to do certain things. So it inspires creative minds. And also, as mentioned earlier, reverse engineering helps us to improve products, perhaps improve in the sense to cut down the cost, bringing the cost down and making it more efficient, more attractive to customers. And at the same time, reverse engineering helps us to develop CAD models, 2D drawings, 3D models for future references as well as product improvement. So those are the major 6 advantages of reverse engineering process. Now, one of the first things that we need to do in reverse engineering, as I mentioned at the beginning, is to decompose the product or disassemble the product into different parts. So usually most products are made using several sub-products or subsystems. For example, if you take a motor car, so you have wheels, engines, transmission systems, bodies, chassis, brake system, suspension system, and the interior seating and things like that. So we can decompose complex product into their subsystems. And then again, we can disassemble each and every subsystem to part level and understand how each of these subsystems work. And for example, if you, since I took this example of motor car, can you imagine how many parts a typical motor car would have? In fact, a typical small motor car would have roughly about 30,000 parts if you go down to the nuts and bolts. So there are so many parts. So the reverse engineering of this kind of complex systems are quite challenging and time-consuming process. Now, for a small handheld drill machine like this, if you take all the parts out, so these are the parts of this hand drill, and it can have about 200 parts. And taking all these parts out and investigating of these parts would help us to further improve the performance of these products. So that is, as I mentioned earlier, is the requirement of this reverse engineering. And also this reverse engineering helps us to understand the interaction among components, how each and every component fit together and why they are fit together and how they operate together as a unit and things like that. Under this Me220, we are not going to go into complex systems like automobiles with 30,000 parts, but I'm going to give you a small exercise, something like a sprayer like this. And if you dismantle this product, so you might find parts like this. If you count, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and about 18 parts. And some of the parts could further be dismantled, like this one. So in this particular exercise, what I want you to do is, we'll group you into about 8 groups, and we'll give you a product like this for each and every group. And you have to carefully dismantle the product, take the parts, each and every part out carefully without breaking. And you have to understand the functionality of each and every part. So why this part is there, for example. And then after taking all these parts out and doing your measurements and all these investigations, we expect you to put all these parts together again and reassemble the product. Therefore, it is very much important and advisable for you to take photographs at each step when you are taking parts out. So take photographs in series as each and every part is taken out. So when it comes to reassembling the parts, if you're not sure of how they are going to be put together, then you could refer to these photographs and do the reassembling. So the exercise is all about dismantling the product. And as I said earlier, the taking snapshots as you do that. And tabulate all parts clearly, showing all role and the function of each part. So I will provide you a template, and you have to fill the template. And then you have to sketch each and every part. And then we'll give you some measuring equipment. So you could measure these parts using each dimension of the part using those instruments, and mark these dimensions on your sketches. And then using SolidWorks, you could model each and every part. And I strongly advise you to use parametric modeling techniques, because as a part of this exercise, we are trying to obtain several versions of this product with different parametric modeling tools or the techniques will help you to do this resizing of components very quickly rather than remodeling right from the beginning. Then we expect you to select the correct material for each and every component, and then apply colors and things like that accordingly. And we want you to create 2D multi-view drawings, production drawings, because the whole idea of reverse engineering is, in fact, to recreate it physically. We are not going to do the recreation here. So we are going to stop at the modeling level and obtain all the sub-assemblies and explore view of all components and things like that. And you could use SolidWorks tools in SolidWorks to find the volume of the bottle. For example, if you want the center of mass of the bottle, and then you can obtain two different size of sprayers, 750 milliliter and 1 liter capacity. So the exercise will be uploaded in the web page. So that is what we expect from you in the next 2 to 3 weeks. So this is the reference.